Bismillahirrahmanirrahim. Hello and welcome to my channel Technically Explained. In this video we are going to solve the final term examination paper of Spring 2023 Electrical Department UET Peshawar. In the first part we have the MCQs. The number 1 MCQs asks audio signal cannot be transmitted directly without modulation because. Now we know that audio signal is a low frequency signal and we also know the relation between the wavelength and frequency which is C is equal to F lambda. Fine. Which implies that lambda is equal to c by f, where c is the speed of light. Now if we have lower frequency, the antenna size will be very large. The wavelength of antenna is about lambda by 10, which is 1 by 10 of the wavelength of the signal. So now the antenna size will be very large and impractical. So that's why here the correct answer is D. Number second, the bit rate for a signal which has a sampling rate of 8 kilohertz, where 16 quantization levels has been used is. Okay, so you are given the sampling rate that is 8000. 8 kilohertz or 8000. I can write this as 8000 samples per second. So we have 8000 samples per second because the sampling rate is 8 kilohertz. Now we have 16 quantization levels. Here L is equal to 16. And we know that to find the number of bits required to encode each sample, that is given by 2 power n. So 2 power n is equal to 16, which implies that 2 power 4 is equal to 16. So n is equal to 4. So we have 4 bits required to encode each sample. So 8000 samples per second multiplied by 4 bits are required for each sample. Now if you multiply both these two, we get the bit rate. So 8000 multiplied by 4, we get 32,000, and samples going to cancel out, so we have 32,000 bits per second, which is the bit rate. So here the right answer is A, which is 32,000 bits per second. For AM receiver, the standard intermediate frequency. The intermediate frequency in case of AM receiver is 455 kilohertz. In case of FM receiver, it is 10.7 megahertz. So here the right answer is B. Now question number 4, the message signal has a bandwidth of 3 kHz. The bandwidth of the double sideband suppressed carrier DSB-SC signal will be. Now because we have a double sideband, in double sideband the bandwidth becomes double. So here double of 3 kHz is equal to 6 kHz. So the right answer is C, which is 6 kHz. If it was single sideband, then the answer would have been 3 kHz and so on. The frequency of dual band Wi-Fi signal. The dual band of Wi-Fi signal has 2.4 GHz and 5 GHz frequency. Next MCQ number 6. The video calling was first introduced with the invention of which generation cellular technology? The video calling was introduced with 3G cellular technology, which is the third generation cellular technology. In 4G it became more pronounced, but it was introduced with the invention of 3G cellular technology. Number 7, the analog communication is used in which generation of cellular communication? Analog communication was used in 1G cellular communication. From 2G we have started the digital cellular communication. Fine, so we have the analog communication was used in first generation of cellular communication. Number 8 says that the message signal is given as m of t 2 cosine 100t plus 18 cosine 2000 pi t. The bandwidth of the message signal is. Now when we have addition or subtraction for that matter, the bandwidth of the signal is the highest frequency in the signal. Now in this signal, in this message signal, we have two frequency components. One is omega 100 and the other is omega 2000 pi. And we have a plus sign in between. So we are going to look at the highest frequency. So in this case, omega is equal to 2000 pi. Now if you want to find out the frequency, we have to divide, or I can say omega m, because this is the angular frequency of the message signal. M stands for the message signal. So Fm is equal to 2000 pi divided by 2 pi, which comes out to be 1000. And its frequency, its unit is hertz. So here the right answer is 1 kilohertz. Number 9 states that in the above question, the peak amplitude of the message signal. Now if you can see over here, you have a cosine over here and cosine over here. If we put t is equal to 0, we are going to have 2 cosine of 0 degree plus 18 cosine of 0 degree. And we know that cosine 0 is 1. So this will be 2 into 1 plus 18 into 1. So this will be 2 plus 18, 20. So the peak amplitude of this message signal is going to be 20. Finally, the last MCQs, which was a bit complicated, but not that much complicated. So the bandwidth of the message signal, again, it's asking what is the bandwidth of the message signal. We have x of t is equal to cosine 10 pi t cosine square 100 pi t. Now let us first find the frequency of this cosine square term. Now because we have a square over here, the frequency or the angular frequency of this signal will be 2 omega. Here you can see that omega is equal to 100 pi. So here we are going to have 200 pi, and if you want to find the let us say that this is your what can I say, this is your omega 1, fine, this is your 200 pi. Now we also have a 10 pi over here, and these two signals are multiplied together, and whenever we have a multiplication, cosine AT multiplied by cosine BT, because these will be added and subtracted, and we know that when we are considering the bandwidth of the message signal, we see the highest frequency. So we are going to be interested in the A plus B term and not the A minus B term, which is the trigonometric identity. So again we are going to plus this 10 pi with this thing, because this is multiplied by a signal whose angular frequency is 200 pi. So these will be added over here. So again here the omega is what? Let me call it omega 2, that is 10 pi. So now the omega is 10 pi because we have an addition over here, 10 pi plus 200 pi. Omega comes out to be 210 pi. Now if you want to find the frequency, because we are given in hertz, I am going to divide it by 2 pi. So f is equal to 210 pi divided by 2 pi, and it comes out to be 105, and because its frequency's unit is hertz. So the right answer of this question is C, which is 105 hertz. This was all about the MCQs, the subjective portion will be covered later on in the next video. Thank you.